Okay, we'll come back to calculus and the statistics. Just let me remind you what we've been talking about since we started this semester. We mentioned that at the beginning of this semester that we have 5 topics to cover in calculus and the statistics. These topics are the progression, sequence, series, and we talk about the first topic where we discussed the idea of having sequence or progression and the pattern and then we classify them. We started with arithmetic progression, then geometric group progression, and we mentioned that different type of progression. We can't extract the pattern from having look about to the numbers, the set, and then we tested these sequences, these series in terms of convergent or divergent, where we have a procedure we can follow to see if they are converge or diverge, which is useful, let me say, property because we are going to predict or forecast what will happen next. I'm talking about the future. And the second topic discussed is the data presentation and the statistics. If you remember, we mentioned that we can present our data organizational method or in a graphical or pictorial method. We let me say revise the different type of graphics or let me say pictorial methods we know, as example line graph, bar graph, polyline graph, bar graph, chart, histogram, relative, cumulative. We discussed the procedure how to plot the set of data using histogram and how we can look inside the data. Then we discussed the summarizing the data using statistics. I mean, how we can look into information inside the data by summarizing in some type of stat points such as mean, median, variation, variance, coefficient of variation. Also, we use Excel to plot them. Now, after we finish this, we will go for the next one, next topic, which is the probability. And after the probability, we'll discuss the fourth topic, which is Laplace transform, and then partial differential equations. So these are the 5 topics to be discussed. Today we'll talk about the probability. But before we talk about the probability, just let remind you that until now we've been talking about deterministic values. It means values we are sure that this is the output. We know the output. Now, when we go for a probability, we will look to something it's not happened. We are not sure 100% that it will happen, but we look to the probability of it get happened in the future. Okay. So I will take you about today. It's just theory in this lecture. Later we will solve the problems, but just maybe one or two examples at the end of this lecture. But probability, I will take you probability distribution, event, experiment, example, and exercises. So today, just let me say, introduce the topic as a probability. You may ask why probability for many reasons. I just here put tips for them. Okay. You can see the slide, right? Can you?
Yes, doctor.
So,
Yes, doctor.
Yes, doctor.
thank you. We can use probability to manage risk or selecting and decision making, understanding the performance, understanding cause and effect, data collection, implementing solution, designing, analyzing a process, and many others. Each one of them, we have infinite number of examples here. Okay, so it seems to be it's very useful. Now imagine that the computer today, the process inside the computer, we deliver many things about computer for our students in electrical and computer engineering. Most of the process based on the probability. So two examples here to compare deterministic and let me say random process. Deterministic, something determined, we are sure about it. The outcome, the output is known for me and I know it. As example, if I have here 1 kilogram, whatever the weight of something material or whatever, and there is 1 meter 1 meter per second, square seconds is the acceleration apply across it. Then multiplying the mass by acceleration will give me I know that this is exactly the force applied across this 1 kilogram of material. Another example, if I have a voltage, let me say, sorry, current, and I have resistance, 10 ohms times 2 ampere, it gives me 20 volts. This is ohms. Ohms say this rule, I just substitute, I come up with the output. So this is what we call a deterministic process. We know the input, we are sure from the output because we have rule, we have formula, it's clear. Now this is not my talk here in probability. In probability, I will talk about random process. Random process. Random process, we are not sure. Maybe and maybe not. Okay, it's not exact, let me say, solution. Example, if I have coin, okay, I toss it 50 paise, 50 paise, I toss it by my hand in this way. So I will have, my output will be either head or tail, 50% head, 50% tail. So I cannot say I'm sure it will be head or I'm sure it will be tail. I will say 50% probability, probably 50% could be head and 50% could be tail. Now, in this lecture, I will define and introduce the terminology of probability. I mean, terms, and I explain them, we define them, and later when I finish the terminology and the rules discussed today, I will start with the two examples. Inshallah, hopefully in the class, we will get more, I mean, let me say, experience in solving problems in probability. So back to probability, experiment is the process by which an observation is obtained. Example, when I toss the coin, this is experiment, okay? When I toss, let me say, dice, this is experiment. So experiment is the process, as I mentioned, and then we got observations, which is, these are our outputs from the experiment. Event is the outcome of an experiment. It means when I toss the coin, I got head, I got tail. Head is an event, tail is another event, you see? So events produced by the experiments. Experiment is what I do, the process, and it's come up with outputs. These outputs represent events. Example of event is the basic element to which probability is applied. When we have experiment, we will have event. It could happen, it could not. Example, record an age, okay? Example, event A, we are talking about here recording age, okay? It could be any age, but I defined one of the output to be A, event A. I call it event A. This event is person is 30 years old. Any person 30 years old is in this event. This is one of the outputs. Another event, I call it B, capital here, okay? Is person is older than 65. Any person older than 65 is falling in this, let me say, event, which is event B. But have a look at A and B. They are from the same experiment, which is record aging, because they are talking about age, right? Another example. Experiment toss a die. Die, you know, when we toss a die, we have from 1 to 6, the output. A, I don't know why, not it, actually. When we toss a die, A observe an output, okay, so observe an odd number. So if I define one of the output from this experiment to be event A, what is this event? I define this event to be odd numbers. It means it could be 1 or 3 or 5. Another event is observe a number greater than 2. It means greater than 2, it means 3, 4, 5, 6. This is the event B. So again, event is taken from the experiment output It could be one value, it could be set of value, but part of the event output. You see here example, here tossing a coin 3 times. This is the coin, 50 paisa. I toss it 3 times. The first time I got either head or tail. The second time head or tail. The third time head or tail, right? So when I toss it, I come up with different outputs. Now, if I define the event to be, as example, 2 heads, okay? We will explain this example, by the way, in details later, but just here to have an idea about events, examples about events. It could come in this way. The first time it was head, the second time it was tail, the third time it was head. Or it could be head, head, tail, or it could be tail, head, head. This is my event. This is my options coming from this event. Another example. Picking real number x from 1 into 20. Any number between 1 and 20 is within this experiment. I defined an event coming from this experiment to be choose number at most 8.23. It means x less than most, it means the highest value, the highest, most value, the highest value. It means x supposed to be less than or equal to 8.23. This is my event. See how we write it. We write it between two brackets in this way, x lower than or equal to the number. Now, while I'm defining the terms here, okay, I'm around to finish, okay. While I'm defining the terms here, notation, let me say, we can write it in this way. P of A, P between two brackets A. What does it mean? Probability of event A. We are going to work to find the probability of event. We will see how to find the probability of event. Now, the first rule I would like to mention here, probability of things to happen is greater than 0 or lower than 1. 0, it means it will not happen. 1, it means everything happen. And in between is the probability. It's supposed not to be greater than 1, not lower than 0. We need to keep this in our mind. If we did our calculation, we got a probability greater than 1, we mean something wrong, because the highest value for a probability is 1. When it's become 1, it means it is deterministic now. We are sure it means. Now let me see, now I defined the experiment. I defined the event. Event is one of the part of the outputs of the experiment. Now let me define sample spaces S. Sample space of a random process is set of all possible outcomes. What does it mean? Now let me ask a question here. If I toss tail, if I toss coin, then I come with either head or tail. So I have two outputs, only head or tail. Now, if I toss, let me say, a die, what are my outputs? What do you think? What do you think the output?
1 to 6.
Excellent. From 1 to 6, it could be 1, 2, 3, 4, 5, 6. Outputs represent the sample space. You see here? 1 coin give me either head or tail. 3 coins, these are my options because 2 to the power 3, 8. So I have 8 options. Head, 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 tail, head, 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 tail, 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 head, tail, 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 head, tail, and so on. If I toss, or let me say, rule a 6 sides dice, this one, you can see here to the right, I come up with sample space would be 1, 2, 3, 4, 5 into 6. These are my options. Okay, these are all the expected output. Okay. Now, when he say as example, the pick a real number x between 1 to 20, what are my outputs? It's all numbers from 1 to 20. Very simple. So this is called sample space, mean all outputs together. Sorry. Now let me mention to rule number 2. Rule number 2 for probability. The probability of the whole sample space. It means all outputs supposed to be 1. If all of them there, it means it is 1. Probability of sample space is 1. Now the die toss. Die toss, have a look. If I, let me say, toss the die, I come up with 1, 2, 3, 4, 5, 6. These are my outputs. Okay, I can write it as S between two brackets, E1, it means event 1, comma, event 2, comma, event 3, event 4, event 5, event 6. Or I can write them 1, 2, 3, 4, 5, 6. If I want to plot them, just to have an idea how they look like, I make a square. You see here, this is the square. And this is S to say that this is sample space. And inside the square here, if you can see, I put my events. It could be E1, E2, E3, E4, distribute them in any whatever the way. At the end, these are my outputs in the sample space. Now, event in sample space, let me define event within this sample space. The same example. If I define A is an event, an odd number. So I'm talking here about 1, 3, and 5. If I'm defining here another event to be B, a number greater than 2. Greater than 2, it means 4, 5, 6. If I wrote them in equation, I will say A is E1, 3, 5, because these are the odd numbers. I can circulate them. You see here this circle? This circle represents event within the sample space of our example. If I define B are numbers greater than 2. They should be 3, 4, 5, 6. So I circulate them in this way. So in this sample space, we define here two events, A and B. We define them by writing them as a text. As example A, add an odd number. Or we represent it by formula, as you can see here, between two brackets, E1, E3, E5. Or we circulate these output inside the graph here, and that's this figure and the sample space. Now let me again summarize what we started with. We started with the definition of a probability. We discussed the random process. We compare it with the deterministic process. And then we define the experiment. And then we define event. And then we define sample space, which is all output of the experiment. Now, let me go for another example. Let me assume I toss a die 3 times. The first toss, okay, I come up with head or tail. The second time I toss it, okay, also head and tail. If I add it to the first result, which, as example, if it is head, either I come up with head or tail. If it is tail, I come up either with head or tail. When I toss it the third time, also for each head, there is head or tail. For each tail, there is head and tail, and so on. So if I come to find the outputs coming from the sample space from this experiment, I will say, see here, head, 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 H, H, H. Head, head, tail, H, H, T. And head, tail, head, H, T, H. Head, tail, tail, H, T, T, and so on. You see, these represent the output in the sample space, all expected outputs. Now, if I defined event A to be getting exactly 2 heads, let me see. In the first output, it is 3 heads. The second output is 1 head. Okay, this one accepted. Okay, I take it. Okay, exactly 2 heads. Okay, the third one, head, tail, head. This is also in the output. Head, tail, tail is not in the output. Tail, head, head in the output. Tail, head, tail is not in the output. Tail, tail, head, not in the output. Tail, 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 not in the output. So I circulate these outputs, HHT, HTH, and THH. These are my output in event A. Because he told me that getting exactly 2 heads. I put them here between 2 brackets. Another example, toss 3 coins. The total number of simple events is 2 by 2 by 2 eighths. Okay, because each time I toss the coin, I have 2 outputs. When I toss 3 times, it means I multiply 2 by 2 by 2, which give me 8. Toss 2 dice. 1 die, it gives me from 1 to 6. 2 dice, It means 6 by 6 because the options will be 36. I will show you a table later on how we got these 36. Those 3 die. Now I multiply 6 by 6 by 6, which give me 216. Okay. Combination of events. Now have a look here. Let me define the complement A of A. Event A, its complement written this way, A to the power C. A to the power C. It means complement of A. Okay. This complement of A represent everything excluding A. It means A event is defined. Now when I come to find complement of A, it means everything in the sample space excluding A. It can be written this way. P power probability of A complement equal 1, which means all the options minus P of A. Don't forget 1 because we say that the sample space probability is 1. It means all options minus probability of A. Now let me define union and intersection. I define it here from this graph. It will be easy. See here, this square, the first square, okay, is sample space for experiment called U. We have event A, we have event B. You see the shaded area here? Shaded area here represent event A. Only A. Complement of A, I shaded everything in the sample space excluding A. You see, I keep it without shadow. Union of A and B, everything in A and B. Intersection of A and B, only the part appear in A and appear in B. We represent union by U and intersection by opposite of U. Still with definitions and the terminology, complementary event with a standard 6 sided die. Okay. Let's say we are ruling the standard 6-side die, and our event A is rules a 5 or 6. The output 5 or 6 came in event, we call it A. So if I want to find the complement of A, it means everything excluding 5 and 6. So it means 1, 2, 3, 4, right? This is the complement. Another example. We flip coin 4 times in a row. What is the probability you get at least one head? One head. Now, when I come to toss it this way, in each time I toss the coin, I got either head or tail. It means 50% head, 50% tail. It means 1/2 head, 1/2 tail. So when I want to find, if I toss it 4 times, what will happen? It means I multiply 1/2 for the first time I toss, because it's 50%, by 1/2 for the second time, by 1/2 for the third time, by 1/2 for the fourth time. So if I did the multiplication, tell me that it is 1/16. It means when I toss my coin 4 times in series, okay, then I expect that I get head 1 out of 16 options, 16 outputs. Okay. Now, another definition, I defined experiment, I defined the event, we defined the sample space, we defined the complement, we mentioned that the probability of A between, this is rule number 1, between 0 and 1, probability of sample space is 1, probability of complement of A is 1 minus probability of A. Okay. Now let's define what we call it disjoint event or mutually exclusive. Mutually exclusive. If we have 2 events, okay, we call them disjoint or mutually exclusive if they cannot happen at the same time. Example, I cannot say it is dark and white at the same time, either dark or white. I cannot say it is night, day or night. I cannot say it's warm and cold at the same time. If one of them happen, as example, when I say it's warm, definitely I know it is not cold because they cannot happen at the same time. So event A or B and disjoint mean they are the intersection of A and B is 0. They will never intersect. No way to intersect with each other. Example, coin is tossed twice. Okay, so twice, head, tail, head, tail. Okay. Now, sample space is head, head, tail, head, head, tail, tail, tail. Now, event, if I define event A to be head, head, and B to be tail, tail, we call A and B here disjoint or mutually exclusive. Why? Because they never intersect. Head, head is different from tail, tail. But if I defined another event A to be head, tail, and another event B to be head, head, we say no, they are not disjoint because B intersect with A. Where they are intersecting? In head, head. It's appear here and here. So they are not mutually exclusive. They are not disjoint, right? They can happen together. This is clear, just this part. Is it clear, the disjoint event? Are you still with me? Great, great. I'm around to finish, 5 minutes. A probability rule. If A and B disjoint event, okay, then probability of A or B is PA plus PB because there is no intersection between. They should be attained together. They should be happen together. So we can say the probability of A or B. Now, if A and B are not disjoint, then they intersect, right? Similar to the example, last example. This is head, 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 tail, and B, head, head. They intersect. In this way, when we find the probability of them, then we say probability of A plus probability of B minus the intersection, probability A and B. I will give example. Now, if I look here to the left-hand side of the screen, you can see here event A. This is, let me say, die from 1 to 6. I define two events, A and B. A get an odd number. It means 1, 3, 5. This is A. You see here in the circle, 1, 3, 5. And B getting only 6. So B only 6. What do you think? They are intersecting or not? What do you think?
Not, doctor.
They are not intersecting, right? So we say disjoint. It means if A happen, B will not happen, right? The same thing. B happen, A will not happen. They don't happen at the same time. Now, the opposite, not disjoint or not mutually exclusive, okay? They could happen. They could happen together. They could intersect, okay? What we call it overlapping or intersecting. Example, see the right-hand side of the screen. Event A, get a number over 4. Over 4, it means 5, 6. This is, as you can see here, A, 5 and 6. And event B, get an odd number. Odd number, it means 1, 3, 5. 1, 3, and 5. So see here, 5 available in A and available in B. They can happen together. We say these A and B are not disjoint events. They can happen together. Okay? They can intersect. They can overlap. So see here, if I want to find the probability of A intersect B in this graph, you see here, the blue here, okay? The blue is A, the blue circle from this sample space, the black. And here, the pink here, B, represent another event. They intersect here. A intersect B. So if I want, this is not disjoint because they are intersecting. If I want to find P of A union with B, then I will say P of A plus P of B minus the intersection. Do you know why I subtract the intersection? Anybody have an idea? Okay, let me answer the question. Have a look. When I put P of A, it means all the circuit of A. When I put P of B, it means all the circuit of B. So this part, the intersection part, appeared twice. It is taken when I added here A to B, right? So I need to subtract one of these twice times to come up with the probability. Now, we defined the experiment, we defined the event, sample space, disjoint, okay? We define some rules, rule 1 for the probability, or law 1, law 2, law 3, and so on. Intersection, union. Now, another definition is independent event. I'm around to finish, just 5 minutes. Independent events. Event A and event B are independent if knowing that A occur does not affect the probability that B occur. Example, if I toss a coin, I come up with head or tail, right? If I take it again, I toss it again. Also, I can come up with head or tail. It's not related to the first try. First try, whatever I got is not linked to the second try. Got it? So they are independent. We call this independent events. They are not related to each other. And one is not related to the second. Well, as example, disjoint, when we say disjoint, it means if one happens, the second should not happen. So they are dependent. But here, it's independent because there is no relationship. Usually, the probability for independent found by P of A and B is by multiplication. We can find it by multiplication. Okay, multiplication rule. No, I think it's clear, do not need more discussion. Last point maybe, and then I go for rule and examples and close this session. Okay, conditional probability. If A and B, two events, okay, in sample space, conditional probability that B event occur given that A has occurred is P of A, B occurred is P of A and B divided by P of B. It means I have two, let me say, events. I want to find the probability of one of them in terms of condition. Which condition is that the second one occurred, right? The second one occurred, tell me the probability of this one. They are both in the same sample space. How can we find them? Using this rule. If I put these rules together, complement, additive rule, I discuss multiplication rule, conditional probability, we have different rules, we just discussed them. I will use them in examples as you can see here. See this example. Have a look. Suppose, this is the additive rule. Suppose that there were 1,000 students in a college, 1,000. And they can be classified as follows. If we classify them as male and female, then male, this is the number, 40 plus 470, altogether 510. And females, 2 plus 488 mean 490. I will define event B to be the male students, which mean 40 plus 470, 510. Agree? Clear? This event, is it clear?
Yes,
It is.
Great.
yes, doctor.
Now I will define the students, the 1,000 students, in terms of colorblind. We have how many students colorblind and how many are not colorblind. As example, I will call the event A to be colorblind students. I found there are only 42 students, 40 of them male and 2 of them only female. And the others remaining are non-colorblind. These are 470 plus 488. Now, again, let me summarize. I have 1,000 students. I have 2 events in this 1,000 students. Event A is the colorblind students. Event B is the male student. Let me see what you want me to do. You see, A is colorblind. Now, when we come up to talk about colorblind, it's the probability to happen. in this 1,000 students, there are 42 students, right? 40 plus 2, the first row. Divided by 1,000, it means 0.042. This tells me that event A, its probability to happen is 0.042. Okay. Event B, the males, number of males per male per female, with respect to female. They are 40 plus 470, it means 510. 510 divided by 1,000, its probability to occur is 0.51. So I know the probability of male students and the probability of colorblind students. Now C is colorblind and male. He asked me, what is the probability of colorblind male? I mean students colorblind and male at the same time. So what I will use what we call it additive rule. How we use additive rule? P of A union B equal P of A plus P of B minus the intersection of them. Have a look. P of A, I got it here, 0.042. P of B, I got it 0.51 minus the intersection. What is the intersection between male and colorblind? The 40, right?
40.
These 40 students, they are male and at the same time they are colorblind. Okay, so we need to subtract them. Just substitute here. Let me explain. I didn't bring my, let me say, pen and tab, but simply if I circle this circle and this circle, they are intersecting in this part, right? If I call this to be A and this to be B, when I add A plus B, now let me ask a question. The shaded area, how many times it get counted? How many times? When I add them? 2 times. So I want, well, just 1 time is supposed to be. So what I do, I will subtract 1 time, which means between 2 brackets, A intersect with B. You see here? So they are intersecting, so I need to subtract at least 1 of them. Now this is the first example, different way to calculate it. Here as example, we add 40 plus 2 plus 470. These are the numbers. Number for male 470 plus 40, and for colorblind plus 2. So we add them divided by thousands, give me the same answer. Another example, I'm around to finish 5 minutes. Conditional probability. Now I discuss here the additive rule. Let's see another example for conditional probability. Please mute your mic. Please mute your mic. The Academy Awards is soon to be shown. For a specific married couple, the probability that husband watches the show, please the mic. Mute your mic. So if we know that the probability, mute your mic please, that the husband watched the show 80%, and the probability that his wife watched the show is 65, and the probability that both watch the show is 60%. It means there is show, whatever it is, not in any show, the probability that the husband will watch is 80%. The wife will watch is 65%. And if they sit together to watch, is 60%. Okay? Now, if I put them in a table, I will show you. Husband, I will assume husband to be event B. We say 80%, so it should be 80%. And the wife wife, event A, 65%. And both they see the show, they watch the show, is 60. So 0.6 it means. 0.6 is the intersection between B and A. So if I have 0.6, how much left from 1,000 watching, husband watching the show? It was 0.8, right? 80% 0.8. So it means 0.2. What about the wife? Wife is 65%. So 0.6 she watched with the husband. How much left? 0.05. Now if I add all of them together, okay, I should complete the percentage of the show. Okay. Have a look. Have a look. He asked me if the husband is watching the show. So I'm sure that husband, this event B, which is 0.6 plus 0.8, which is 8.8, which is 80%, he is watching the show. What is the probability that his wife is also watching the show? Now he's asked me about the probability for something to happen in terms that another event happened and they are linked to each other. They are not disjoint. They are intersecting. They are overlapping. Then I will say, okay, probability of B, he gave it to me, which is 80%, 0.8. Probability of A, which is for wife, 65%, which is 0.65. The intersection between them is 0.6. Now I have the rule which say P of A, B with respect to B is P of A intersect B divided by P of B. I have both. I have the intersection given the question. I have the probability of the husband watching the show, which is also given in the question, 80%, 0.8. I just need to divide. Now, until this point, we just today discussed the principles, the concepts, the theoretical part of the probability. We define the terms, okay? We define the experiment, event, sample space, mutual exclusive or disjoint, overlapping, union, intersection, additive rule, and conditional probability rule, okay? By the way, this is part of the probability. Later on, we will go for numbers. It means we will see how to find the standard deviation, variance for them. We will do calculations. We will construct tables. It's more, let me say, enjoyable than this part. Here, just theoretical part with more examples with me in the lecture and the tutorial. I think everything will be fine and clear. Do you have any question to this point? Any question?